We're going to do a parabola application question. This one's about projectiles. Let's say we throw an object and its height after t seconds is negative 5t squared plus 30t plus 35. So we'll plug in a number for t. That's how many seconds after it was thrown we're asking about. And then the answer we get out of this equation is going to be the height itself. When does it hit the ground? What was its maximum height? When does that occur? And what height was it thrown from? We're going to do these one at a time. When does it hit the ground is code for you finding the x-intercept. Now here it's actually t-intercept because t is my variable. So if you want to be pedantic, you can call it a t-intercept. But the ground is at a height of 0. So you're solving this equation where the height is 0. 0 equals negative 5t squared plus 30t plus 35. Now your job is to solve this quadratic equation. You can do that by factoring or the quadratic formula. I'm sure you could complete the square too, but this looks a little factorable to me. Let's find out. All these numbers are divisible by 5, so I'm going to pull negative 5. That's the leading coefficient out of all of the terms. Negative 5t squared without negative 5 is t squared. 30t divided by negative 5 is minus 6t. And 35 divided by negative 5 is minus 7. Now, this can be factored further if you can find two numbers that multiply to negative 7 and add to negative 6. I can, and because there's no number in front of this t squared, it means I can toss the numbers that I find straight into brackets with t's. What I mean is the two numbers that times to make negative 7 and add to make negative 6 are negative 7 and positive 1. See how they times to that? And, well, that's negative 7 plus 1 is negative 6. That means t minus 7 and t plus 1 are factors of this equation. Now that means if negative 5 times this equals 0, then either this has to be 0 or this has to be 0. Anything times 0 will give me that 0. So it could either be this one, t equals 7, or this one, t equals negative 1. I'm asking for the t value that would make this bracket equal to 0. What minus 7 gives 0? The answer is 7. What plus 1 gives me 0? The answer is negative 1. But negative time doesn't really make sense. We're asked to plug in how long it is since it's been thrown, and this is technically representing 1 second before it was thrown. It wasn't even in flight at that point, so that doesn't make sense. When does it hit the ground? The answer is after 7 seconds. Cool. Now, the next question we have here is what is its maximum height? Now, there's lots of ways to find the maximum, aka the vertex of the parabola. One option is to complete the square on this standard form equation. Another option is to use a shortcut formula, x equals negative b over 2a. But because we've already factored this one, and I have two x-intercepts, and again, I know that negative 1 didn't really count, but it is the x-intercept of the parabola that this flight path is. We actually have another shortcut we can use. The axis of symmetry of this parabola is at the average of the two x-intercepts, 7 and negative 1. Now I'm going to be careful here. This is t. I keep wanting to use x, but this is clearly t in the equation. 7 plus negative 1 divided by 2 is 6 over 2, or 3. So the maximum height occurs after just 3 seconds. And how do you find the maximum height? Well, I have a formula for h. h when t is 3 is -5 times 3 squared plus 30 times 3 plus 35. Now that feels like calculator work to me. I can do some of this in my head. That's minus 45 and plus 90 and plus 35. When I do that on my calculator, I believe I get 80 as an answer. So the max height is 80 meters, and it occurs after just 3 seconds of flight. That 3 came from the average of the two x-intercepts. Another popular question is, what height was it thrown from? That's code for asking, what is its height after 0 seconds have elapsed? So this is as easy as saying, what is h after 0 seconds? Well, if I plug in 0 for this t, and I plug in 0 for this t, then I get 0 plus 0 plus 35, which is 35. So it was thrown from a height of 35 meters. And we can combine all of that information to create a sketch. Now I'm going to draw this with just a little bit of extra room to the side here. Time can't really be negative in the context of this question, but I'm going to put my t-intercept there anyways, just to demonstrate. I've got x-intercepts at 7 and -1. So let's put one here at -1, and then 1, 2, 3, 4, 5, 6, 7 might be approximately here. There you go. There's my x-intercepts. My axis of symmetry is directly in between the two at 3. And when I plugged 3 in, I had a height of 80. So I'll go all the way up to here for 80. Now I have to connect these points with a smooth parabola. Let's see if I'm any good at that. Some kind of U shape where it reaches the top. If you shoot a basketball from the ground and you throw it up, it reaches the top of its arc and then starts to head back towards the basket, right? It's supposed to look something like that. Now, I'm going to put a dotted line here to emphasize to you that that is another x-intercept. But the ball was thrown from a height of 35 meters. I mean, I don't know that it's a ball, it's just a projectile. From 35 goes up. After 3 seconds, it's at its maximum. Then it keeps falling. It's back down to 35 here at exactly 6. And if you wonder how I did that, it's because this is 0. It takes 3 seconds to go up that amount and will, by symmetry, take 3 seconds to go down that amount as well. So at 6 seconds, we are 35 meters high, and then it takes 1 more second to fall all the way to the ground. What a beautiful parabola. Thank you for sticking with me there. I hope you learned something, and best of luck.